Morning everybody. Today we are discussing the next topic in the stereochemistry, that is the definition of the conformers, configuration, and what is the difference between the conformation and configuration. See here, this is the representation of the molecule CH4. So the molecular name is methane, and here the central atom in the methane is the carbon atom, and the 4 valency of the carbon atom is satisfied by the hydrogen. And you know that the methane are exist in a tetrahedral geometry, and the hybridization of the methane is sp3. And if you are replacing one of the hydrogen atom by the methyl group CH3 group, we will get the ethane. This is the structure of the ethane. See here, we can see that a CC sigma bond, and all the remaining 3 valency of the carbon atom is satisfied by the hydrogen. And the structure which is shown in the left hand side is named as eclipsed conformation, and the right hand side is known as the staggered conformation, that we will discuss later. Okay. Now, imagine the CC sigma bond is a spring. So if you are holding the one end of the spring in a one hand, and if you are rotating the other end, we will get the different structures of the spring. So similarly, if you are holding the CC sigma bond in your hand, and if you are keeping the one of the carbon atom is stationary, and if you are rotating the other carbon atom, we will get the different spatial arrangement of the atom or a group of a molecule in the 3-dimensional space. So the structure which is shown in the right hand side is only one form during the rotation. And this spatial arrangement of the atom or a group of a molecule in the space is known as the conformers. Now we are moving the definition of the conformers. Conformation means it is a different spatial arrangement of atom or a group of atom in a molecule which arise due to the free rotation about the sigma bond, CC sigma bond. So one of the speciality of this conformers is that they are interconvertible by the rotation about the CC sigma bond, and this rotation is very easy and very fast, and the rotational barrier between the two conformers is very low. Now we are discussing this point in detail. See here, this is the butane molecule. The structure which I shown by the left hand side is the butane molecule. So the butane molecule, the molecular formula is CH3, CH2, CH2 and CH3. So consider the middle CC carbon atom, and so consider the middle carbon atom. So the central carbon atom is attached by one of the valency is attached by the methyl group, and the remaining other is satisfied by the hydrogen. Similarly, the other carbon atom. See here, if you are rotating the CC sigma bond by 60 degree, we will get the another spatial arrangement of an atom or a group of atom in the space. So that is shown by the structure which is represented by in the right hand side. So this rotation is very fast and very easy, and the energy barrier between these two structures is very low, and they are exist in an equilibrium. That's why we cannot separate any of this spatial arrangement, and that's why they are interconvertible. Now we are moving into the next point. These conformers are exist in an equilibrium and we cannot separate the conformers under ordinary room condition. This is the structures. And now we are discussing one more important point. During this rotation only the one part of the molecule is changing with respect to other part about the CC sigma bond, and the atom are connected in the same order without any cleavage or the formation of the bond. See here, if you are rotating the CC sigma bond, the position of the CC sigma bond in the space has no change, and the remaining part, that is the hydrogen, only the position of the hydrogen and methyl group are changing. See, while we are comparing the structure which is shown in the right hand side and left hand side, we can see that in the structure in the left hand side, the methyl group is in the up. So during rotation, the position of the methyl group is changed. That is in the right hand side. So the spatial arrangement of the methyl group is changed. Similarly, the hydrogen, the position of the hydrogen is also changes. So this spatial arrangement is known as the conformation. Now we are moving into the configuration isomerism. Configuration isomerism means it is the specific spatial arrangement of an atom or a group of atom in a molecule that arises due to the cleavage or the deformation of the bond. Consider a chemical reaction, and in the chemical reaction we definitely have a starting material and a reagent. While we are adding the reagent, some of the bond which is present in the starting material will break and some of the new bond is formed. So during this process there is a change in the spatial arrangement of the atom occurs, and this spatial arrangement due to the chemical reaction is known as the configuration. During this change, the chemical bond break or deformed. And the next point is, due to these changes, the structure which is obtained is interconvertible, and it is very difficult, and this interconversion is very slow, and the barrier between these two structures is very high. See here, this is the geometrical isomerism of the 2-butene, the cis form which is shown in the left hand side and the trans form which is shown in the right hand side. So these two forms are example for the configuration, and the structures of the configuration, there is a difference in the position of the methyl group in the space. See here, in the first structure, that is in cis, the methyl group are in the same side, whereas in the trans form the methyl group are in opposite side. And the barrier or the conversion between the cis and trans is difficult, but even then it is possible by supplying the energy. That's why it is written that the conversion between these two structures is very difficult or even slow, and the energy barrier between these two structures is very high. So we can easily separate these two structures. And this is the difference between the conformers and the configuration. Now we are moving into the living examples. So this is the examples of an conformation isomerism. See here, one man is sitting in a chair. We know that that guy cannot stay in that position more than 5 hours. In between he will stand up definitely, and he will walk, for the comfortability. So these are the some of these movements. There is only a movements of the hands and leg occurs during this motion, but the man is not changing and any part of the body is not changing. Only difference is in the movement or the spatial arrangement or the movements of the hand and the leg. So these are the example for the conformation isomerism. And while we are discussing the configuration, see here, one man is sitting in a chair and one leg is replaced by the machine. but definitely he can walk, he can sit, he can stand up, but the difference is we cannot restore his leg. Okay, so this is an one of the exam. This is a simple illustration of an configuration. Configuration means the bond is breaked, or if it is formed, there is a change in the spatial arrangement, and we cannot regain the original structure. Hope you understand the topic. Thank you.